Okay, so let's see here. Once again, these are linear programming things, and we have to take all this information and try to organize it into something that makes sense. Okay? So there's the way that I've been doing this so far has been putting all of the item stuff along the left side, then all the attributes along the top. So let's do that over here. So our items that we're talking about are two airplanes, plane 1 and plane 2. Okay? An airline has two airplanes, plane 1 and plane 2. And they want to transport 2,000 first-class passengers, 1,500 tourists, and 2,400 economy class passengers. Okay, those are the totals, at least a minimum of. So we have three different types of passengers. We have first class, we have tourist class, and we have economy class. Okay, so we're trying to write these equations. I'm going to make this a little bit bigger just so we can see this better. We're about to graph later. Okay, so these are the totals that we're trying to minimum or maximize. We want the most people possible. So first class passengers, we wanted how many? 2,000 first class passengers. 1,500 tourist class passengers, and 2,400 economy class passengers. Okay, so you're setting up this business where you're trying to contract with certain people, and this is how many you want to fly out to at least this many, because of course the more that you fly out, the more money your business will make, and you'll be richer. And of course, we all know richness equals happiness, and the richer you are, the happier you are. Proven scientifically. Not. Anyway, let's see. The first plane costs $12,000 to operate, so that's going to be another thing over here. Cost to operate, $12,000. Once again, we're going to want to minimize this, but it's good to know at the beginning. $12,000 and can hold 40 first class passengers, 40 tourist class passengers, and 80 economy class passengers. Okay, I think the majority of you are okay with doing this part so far. And plane 2 costs $10,000 to operate, so a cheaper airplane, and it holds 80 first class passengers, only 30 tourist, and only 40 economy. Okay. So we're going to try to see where these three equations will cross. So you get an equation from first class passengers. There's one equation here. There's your second equation from tourist class passengers. And your third equation comes from your economy class of passengers. Okay, when you organize your information this way, you always get vertical column equations. Always. It's so nice and so pretty that it always works out like that. Let's make plane 1 X, and we'll make plane 2 Y, so that we can create some linear equations. Okay, because that's what we want to do. You want to make equations so that we can graph them and see where they all cross. Let's make a new page. All right, first class equation was 80x. 80x? Where'd you go? Come back here. 40. Nay, 40x. Erase that. Erase, I say. 40x plus 80 from y, plane 2, has to be at least 2,000. Okay, at least means that this stuff needs to be greater than. Okay, the tourist class passenger, let's go back and remind ourselves what those values were. 40, 30, and 1,500. Perfect. So once again, 40 on the first plane, 30 on the second plane has to be bigger than 1,500. And our last one, our economy class, we had 80 from the first plane. Let's go back and see again. 80 from the first plane, 40 and 2400. 80 on plane 1, 40 on plane 2 has to be bigger than 2400. Okay, now these are some pretty large equations that you get, so we're going to have to solve each of these for y. Solve each of them for y so that we have something that we can graph. Okay, and being that you are older, I assume that you know how to solve an equation for y, which may or may not be a quality assumption. So we'll subtract the 40. 80y is bigger than negative 40x plus 2000, and dividing everything by 80 and reducing, not actually dividing, you get the equation, make it a little bit fatter here, y is bigger than or equal to negative 1/2 x plus, is 25? 25. Okay, that's one linear inequality. Y is larger than this. Okay, we do the similar thing for these other two. You minus your 40 from both sides, plus 1500. Solving this one for y, y is bigger than or equal to negative 4/3 x plus 50. Okay, 4/3 because we want to graph them, so we want to go down 4 units, right 3 units. Not 1.33333, even though that's what this is as a decimal. Leave it as a fraction when we're graphing. And the last one, we'll subtract the 80 from both sides. 40y negative 80x plus 2400. So y is bigger than or equal to negative 2x plus 60. Okay, these are your three nice linear inequalities. Okay, inequalities, y is larger than, because we want to maximize our money, not just see where it equals it, but where can we start maximizing. So these are your three equations that we're going to put on this graph back over here. Let's come back to our graph. It's nicely scaled. We're going to graph these three equations. There we go. There it is. Okay, so the first one, which was in blue, was y is bigger than or equal to negative 1/2 x plus 25. So here's our scale, 5, 10, 15, 20, 25. It starts on your y-axis. You go down 1, right 2, down 1, right 2, down 1, right 2, and all this other stuff. Okay, so here are the points that go along with your first class passengers. Okay, for plane 1. And then y is bigger than or equal to negative 4/3 x plus 50. So here's our 50 and negative 4/3, down 4 over 3, down 4 over 3, and so on and so forth until it goes off the page. And our last one was y is bigger than or equal to negative 2x plus 60. So it starts at 60 and goes down 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and so on and so forth. Okay, so we could put in these lines and you can see that of course they're all linear, but what we're really looking for is where these things cross. So here's one place where this purple line crosses the red line, maybe pink, can't tell my colors, or down here, here's your other point. So we have two different options for answers. We can either have 15 plane 1s, because your x-axis goes with plane 1s, and 30 plane 2s, okay, because this point is 15 comma 30, Or we could have 30 plane 1s and 10 plane 2s. So here we have two options, and you want to remember minimize your cost. So your costs are $12,000 for plane 1 plus $10,000 for plane 2. Okay, so we can do that quickly down here. Your cost, 12,000 times, let's try this point first. 12 times 15 plus 10 times 30. Should we do it on the calculator? Okay. 12 times 15. That's 180 plus 300. So if we used 15 plane 1s and 30 plane 2s, that would cost us $480,000. Because remember, these units are in thousands. So what about if we used 30 plane 1s and the 10 plane 2s? Okay, we're going to try this point now. And if we do that, 12 times 30 plus 100, 10 times 10, is 460. So because we want to minimize cost, we should probably use the second amount of airplanes. So over here on your answer grid, we would like 30 of plane 1 and 10 of plane 2, and that would cost us $460,000 to do that way. Okay, which is cheaper than doing it the other way. So that's what we're trying to do, is figure out where all these things are with the equations so we can graph them and see where they cross. Zero.
My soul will not rest in peace.
Your soul cannot rest in peace. Okay, so this is one of the more extreme ones where we have three different attributes to each of our two items, or your two variables. Okay, first class, a tourist, and an economy class. You get equations from each of those three things. And then trying to solve them both for y and graph them. Yes, it's quite a lot of algebra to do, but it is an algebra class, so that's what you should expect. Okay, now the second one here is a little bit different. It's more like the Omar and his truck. Okay, so let's say we have lumber and we have plywood. Lumber and plywood is what this mill makes. Okay, it can make 400 units of lumber and plywood. Okay, that's the maximum weekly production capacity for this mill. So some amount of lumber plus some amount of plywood cannot exceed 400. Okay, that's your basic linear relationship. Some lumber plus some plywood cannot exceed 400. Okay, that's equation number one. Now the other two are your constraints. You have to make at least 100 units of lumber, so at least 100 units, and at least 150 units. Okay, those are your other two equations. And then we have, of course, a profit function that we want to maximize, $45 for every unit of lumber and $70 for every unit of plywood. Okay, so these ones with constraints, yeah, you want to put 150 here and then the total. Okay, just try to not make crazy things. You know you're going to have more than one equation. There's your basic equation of the relationship between your two things, and then there is these two constraints. Just like with the gas problems, you have a gas tank that can only hold so much gas. Okay, here we have to produce this much lumber, we have to produce that much plywood. So these are your three equations, the sum equation, and then you have your two linear constraints. So if we come over here to our graph, Let's let lumber be your X variable, and we'll make plywood be your Y variable. So we have to have at least 100 units of lumber. So that would be this, at least 100 units. We have a vertical line going here because it's a x-axis, a vertical line going here, at least 100. So we can produce 200, 300, 400, nothing more than 400. So anything out here is perfectly okay of lumber. And then we have plywood. Plywood has to be 150, 100, 120, 140, 160. So 150 is in the middle here. Here's your 150 worth of plywood. Okay, your minimum that you can make. So all of this, you can make 200 or 300 plywoods, whatever. So now we have this whole entire system up here. It's also a possibility. So we want to use using up here, making more plywood and more lumber so that we can have more profit. But then our third equation is lumber plus plywood is 400. So that means that, let's see what color, how about red? That means that plywood has to be bigger than negative lumber plus 400. So that starts at 400 and it goes down this way, -1 slope. So you have this, basically this nice triangular region up here that's going to be your solution possibilities. Okay, this one here. I guess red doesn't show up very well, does it? You see that? I cannot. So this is your most viable solution set, this triangular region here. So we need to test this point of vertex. We'll make 100 lumbers and 300 plywoods. We need to check this vertex point here, which is 250 lumber and 150 plywood. Or this one here, 100, 150, that's not even maximizing your 400. So we really don't have to worry about that one. That's not an intersection point. So 100, 300 or 250, 150. So let's come back to our cost or our profit function and see which one gives us the most amount of money. Okay, 100, 300 or 250, 150. Correct? Let's see. 100, 300, 250, 150. Okay. Remember, the first one is lumber. So 45 times 100 plus 70 times 300, or 250 times 100 plus 70 times 150. So back to our handy dandy calculator. Let's move it over here so we can see what we're doing. 45 times 100 plus 70 times 300. So if we make this amount, we could earn 25,500. Or if we do the other way, 250 times 100 plus 70 times 150, we would make 3550. Oh, this has to be 300. No. Ay caramba. 45 times 100. That is incorrect. Why didn't any of you tell me that was incorrect? Because you were doing it yourself? Good job. Okay, 45 times 250. This needs to be 250. I'm just going to erase it. This is getting ugly looking. 45 times 250. Okay, equals 1150 plus 70 times 150. 21,750. So according to your profit function, you should be making 100 units of lumber and 300 units of plywood for a total profit of $25,500. Okay, so yes, I agree. The hardest part about these things is writing the equations. Okay, is there one relationship? Is there two relationships? Are there three relationships? Is it a constraint problem where you have to make at least this or at most that? Or do you have a total and you have two different variables that add up to that total? Okay, these are basically the two different types of problems you have. Sometimes there's only two equations, and that's a nice easy one because you only have one answer to check. But sometimes there's three where you have two different answers to check. Okay, so there's lots and lots of different things that can happen, but these are basically your two types of equations when you have linear programming.